Now we'll discuss about the properties of cross product or properties of vector product. In order to discuss the vector product or cross product, first we'll take two vectors. One is known as A vector, the other one is known as B vector. So the very first one is if we take the cross product between the two vectors, A cross B, that is nothing but a cross product between the two vectors, that A cross B will not be is equals to B cross A, because they will be in opposite direction. So when A cross B is not equals to B cross A, then we will call this one as the property which is not satisfying the commutative, or the A cross B is not equals to B cross A. It shows that it is not satisfying commutative property. Now coming to the distributive property. Here we are going to take three vectors. One is known as A, the other one is known as B, while the last one is known as C vector. In such a way that A vector cross B vector plus C vector is equals to, we'll write it as A cross B plus, the next one is known as A cross C, and we'll call this one as a distributive property. As we are multiplying A from the left hand side, we can even call this one as a left distributive property also. So that is A cross B plus C is equals to A cross B plus A cross C. And coming to the third one, in order to define the vector product between two vectors A and B, we will take two scalars also. We will call it as L and as well as M, in such a way that LA vector cross MB vector is equals to, here L and M are scalars, while A and B are known as vectors. We will write this one as LM as it is in the form of product into A cross B, that is known as a vector product between the two vectors A and B. So here we are calling LM as scalars. For some scalars, we'll write it as L comma M. Whereas the last property is known as the magnitude of A cross B is equals to always the magnitude of B cross A. Usually A cross B is not equals to B cross A, whereas coming to the magnitude of both A cross B and magnitude of B cross A, both are equal, right?